Welcome to Study Loop.
Okay, let's take a look at three different statements about equilibrium constants and assess whether or not they're true. The first statement is that the equilibrium constant is never negative. To think about this, let's look at the definition of the equilibrium constant. It is a ratio of products over reactants. Since concentrations are always positive, we are always going to have a ratio of positive numbers here. Therefore, letter A is true. Equilibrium constants will never be negative. B. Drawing a single arrow means the equilibrium constant is close to zero. Let's take a look at an example. If I drew a reaction like this, what this really means is that A goes to B so quickly that it is effectively not an equilibrium, but a one-direction type of reaction. If I had to assign a Kc to this, I could think about it in terms of Kf over Kr, the rate of formation over the rate of the reverse reaction. In this case, A going to B is very fast compared to the reverse rate, so much that the reverse rate is negligible. So we would end up with a very big number over a very small number. That ratio then would be a very big number, which would be far from zero. So this second statement is false. An equilibrium constant closer to zero would happen if you had two rates that were similar to each other, and you had a similar concentration of both at equilibrium. Finally, letter C, a bigger equilibrium constant means you reach equilibrium faster. While equilibrium constants tell us about the ratio of rates, in this case Kc, as shown above, is Kf over Kr, this is just a ratio of the rates. They could both be big or they could both be small. Equilibrium is good at telling you what concentrations to expect at equilibrium, but from the constant alone you can never tell what the actual time for equilibrium to be reached requires. That is a separate topic called kinetics. Therefore, this answer is also false.